Right, good morning, everyone. Well, people, today we're going to continue with the cubic graph. I'm going to spend around about 5 minutes on the revision that I taught you last week on the cubic graph, and then we're going to continue with it. So there's two things that you will get. You will get to sketch the cubic graph, or the cubic graph will be sketched and you need to answer questions on it. That's a definite question. Okay, let's quickly have a look at the following. People, once again, in the cubic graph is given by the equation fx is equal to ax cubed plus bx squared plus cx plus d. If a is positive, that means we're going to heaven. So we start in hell and we land up in heaven, and that's the shape of the graph. If that a value is negative, we are going to hell. So we start in heaven and we land up in hell. Right. So that is the shape of the graph where the a value is positive and where the a value, which is the coefficient of x cubed, is negative. Now, people, you can also get the following graph. If a is negative, we can also get a graph like that. We go quickly to hell. And if a is positive, we're going to go quickly to heaven. Now, people, take note. When do I get these graphs? This here is also a cubic graph. But the cubic graph can also look like that or like that. And when would it look like that? This here, if your stationary point and your point of inflection is the same point. Then the graph can look like that. This is your stationary point and your point of inflection is the same point, and a is negative. That means I'm going to hell. I start in heaven and I land up in hell. That remains the same. However, if the a is positive, it can look like that. And when does the cubic graph look like that? When the stationary point and the point of inflection is the same point. I'm going to do an example of that with you next week. All right. I'll discuss that in detail. People, I've also stressed last week, terminology is of utmost importance, because if you understand what they are asking, then it's easy to interpret the question. For example, if fx is a y value, and fx is a function, and it can also be a non-function. When is it a function? If the vertical line test cuts the graph once, if it's one-to-one mapping, for every x value, I've got one corresponding y value. When is it a non-function? If the vertical line test cuts the graph more than once, and for every x value, I've got more than one corresponding y value. What is f prime x? People, f prime x is the gradient of the line. F prime x equal to 0 is the stationary point. F double prime x equal to 0 is your point of inflection. And f double prime x greater than 0, that there is concave up. And if f double prime x less than 0, that is concave down. Now, people, I did this with you last week. Last week, we did not answer 9.5. The time was up. In the June 2017 paper, this question I did with you last week. Now, in 9.5, they said, write down the values of x for which f prime x is less than 0. Now, take note. Put down all pens and listen. What do we know about f prime x? What is f prime x? It is the gradient. F prime x is the gradient. Now, what are they telling me? Where is f prime x negative? Where is the gradient negative? The gradient is negative there. Do you see that? It's a downward slope. So where is it? For which x values is the gradient negative? Between x equal to negative a third and x equal to 1. X is greater than negative a third and x, or x is an element of negative a third and 1. We can use round brackets because those values are not included. That is interval notation. If it's included, we use square brackets. If it's not included, we use round brackets. Are you happy with that? Right, so now we've answered that question, the June 2017 paper. That question 9 is fully complete now. Now, people, what I did last week, I drew the cubic graph where A is positive. Now I'm going to draw a cubic graph where the A value is negative. Now, the first thing we got to do is we got to understand the question. People, in this case here, A is negative. So what is the shape of the graph? It starts in heaven and it lands up in hell. That's the shape of the graph. For this graph here, where it's got x cubed, x squared, x and a constant, it will not look like this graph here. This graph here will only have x cubed and a constant, or only ax cubed in. That is where the stationary point to the point of inflection will be the same point, and this will be the shape of the graph for a less than 0 and a greater than 0. Is that clear? So it's not going to be that graph, it's going to be this graph, and it's going to look like that. So let's look at the following. Determine the x and the y intercepts. Now, people, x-intercept, we've got to put y equal to 0, correct? That's fine. But before that, we need to find the first factor. So to find the first factor, you can say fx equal to 0. So it's negative x cubed, negative 4x squared, plus 3x plus 18 equal to 0. That's fine. Not a problem. What we need to do now, people, we first of all need to find the first factor. So I'm going to use this side of the page. Fx is equal to negative x cubed, negative 4x squared, plus 3x plus 18. Now, to find the first factor, I'm going to use trial and error. I'm going to try the f of 1. Wherever there's x, you put 1 into the equation, use your calculator. If it gives me 0, it's a factor. Now, I'm not going to do the f of 1. Okay. I'm going to try the f of negative 1. Then I'm going to try the f of 2, and then negative 2, etc. So 3, negative 3, 4, negative 4. If you still don't get 0, you've made a mistake. Go back and redo your calculations. So I'm going to say, let's try the f of 2. I'm going to start with 1, negative 1, 2, negative 2, 3, negative 3. Let's try f of 2. So wherever there's x, you put 2. So it's negative 2 cubed minus 4 times 2 squared, 3 times 2 plus 18. That is negative 8, negative 16 plus 6 plus 18, and that gives you 0. So if f of 2 gives me 0, it means it is a factor. So if it's a factor, then x and the opposite sign, x minus 2, is a factor. Right, people, that's your first thing you need to do when you want to factorize a cubic polynomial. Is that clear? So, what am I going to do in this case? Right, what I can do is I can multiply across by negative. So then I'm going to get x cubed plus 4x squared, negative 3x negative 18 equal to 0. And we know that x minus 2 is a factor of that expression. Is that clear? Now, there's many ways in which you can factorize that. You can do long division. You can do the method of inspection. You can do synthetic division. Do the method that your teacher taught you. I'm just going to do the following. And you can learn this method because I think it's an easy method. I say, first times first must give me first. So x times x squared will give me x cubed. First times first gives me first. Last times last gives me last. Negative 2 times negative 9 gives me plus 9 gives me 18. Is that clear? Right, then you say, this here is a trinomial. So this here must be in terms of x. So I'm going to say x times 9 is 9x. What do I need to give me plus or negative 3x? Remember, I'm using this line here. What am I going to use to give me plus, sorry, yeah, that's right. Negative 3x, what must I get to give me negative 3x? I'm using this line here, remember? So I say I need negative 12x. So you can say negative 2 times what will give me negative 12x? Negative 2 plus 6x will give me negative 12x. So now I can find the factors. That's x minus 2 multiplied by x plus 3 times x plus 3 equal to 0. So yeah, x is equal to 2 or x is equal to negative 3. Now people take note. If x is equal to negative 3 and it is repeated, what do you know? If the x-intercept is repeated, it will turn on the x-axis. Is that clear? So if it turns on the x-axis, I know that y is equal to 0. Is that clear? So yeah, we can say that y is equal to 0. Those are your x-intercepts. The next thing, we got to find the y-intercept. So now we say the y-intercept, we need to put x equal to 0. People, if I put x equal to 0 here, I'm going to get y equal to 18. That's my y-intercept. Then we need to determine the stationary point. The stationary point, people, is basically your turning point. Is that clear? Okay, so how do I determine your stationary point? We say f prime x equal to 0. So now we can say f prime x is equal to 0. Now I'm going to find the derivative of that. So it is negative 3x squared, negative 8x plus 3 is equal to 0. Now people, just to make things easy, I'm going to get rid of the negative, which is the coefficient of x squared, negative 3. I'm going to get rid of the negative. Multiply, cross by negative, 3x squared plus 8x minus 3 is equal to 0. Are you happy with that? What are the factors? 3x multiplied by x gives you x squared. And then 3 and 1. This here is 3 and 1. This here is plus and this here is minus is equal to 0. Is that clear? Let's quickly have a look. That there is 9x minus 1x gives you plus 8x. So now we can solve for x. 3x minus 1 is equal to 0. X is equal to a third. Or x plus 3 is equal to 0. X is equal to negative 3. Now take note. Usually, one of the x-intercepts, one of the stationary points is also an x-intercept. And what is your y value? Y value is 0, correct? So yeah, you know that your y value is 0, you don't have to work it out. So to find the y value of this, we're going to substitute f of a third into the original equation. Negative a third cubed. People, you do this on a calculator. Minus 4 times a third squared plus 3 times a third, right, plus 18. And that will give you a value of 18 and 14 over 17. So your two stationary points is a third and 18 and 14 over 27 and negative 3, 0. Those are your two stationary points. Okay. Now they're going to ask you to sketch the graph. People, we know that the shape of the graph should look like that. So what we're going to do is we're just going to follow what we've worked out. What are your x-intercepts? 2 and negative 3. Negative 3 and 2. Those are your x-intercepts. Then your y-intercept is 18. Your stationary points is x equal to a third and y equal to 18 and 14 over 17. Right, is that clear? And what do we know? It turns there. And what do we know? X equal to -3. If the x-intercept is repeated, it turns on the x-axis. And what is the shape of the graph? It comes, we start in heaven, we go through that, and we land up in hell. You've got to show your x-intercept, your y-intercept, as well as your coordinates of your turning points, and that will give you full marks. Is that clear? Are you happy with that now? People, the fourth question that we can determine from that graph is the following. They say to you, for which values of x is it concave up? Right. Now, people, what is the formula for concave up? F double prime x greater than 0, correct? So we've got f prime x here. F prime x we already determined. There it is. Do you see that? So if we define the derivative of -3x squared, -8x plus 8, we're going to get -6x, -8 equal to 0, correct? So here we're going to get, in this case, f double prime x, if they say concave up greater than 0, and if we find the double derivative of -6x, -8 is greater than 0, -6x is greater than 8, so x is less than -8 over 6, so x is less than -4 over 3. People, in an inequality, when you multiply or divide by a negative number or a negative sign, you change the sign of the inequality. So therefore greater becomes less than and less than becomes greater than, correct? So they asked for which values of x is it concave up? For x less than -4 over 3. Now let's interpret that so that you can not only see an algebraic expression, but you can understand the concept. We said, where does concave up and concave down exist? Concave up and concave down exists when you find the x value, which is the midpoint of your stationary points. Your midpoint of your stationary points is your point of inflection. And your point of inflection is used to determine concave up or concave down. Now we said x less than -4 over 3 is concave up. This here is -4 over 3. That is -4 over 3, which is -1 1/3, correct? That point there. We said less than that. You see, any values less than will finally go up. So it is concave up. For x less than -4 over 3, I will finally go up, concave up. For x greater than 4 over 3, do you see I'm finally going to go down, concave down. So for which x values is it concave up? X less than -4 over 3. This here is the explanation of it, where that is the algebraic solution to it. Does it make sense? Are you all happy with that? No problems. So where do we find the point which is concave up and concave down? The concave up and concave down is read from the point of inflection. Is that clear? So that means if this here is the x value for the point of inflection, if I use x values less than, I'm finally going to go up, concave up. If I use all the x values greater than 4 over 3, I'm finally going to go down, concave down. That is the interpretation of it. That is the algebraic solution of it. But you understand where the two come together. Great. Let's look at the following. People, you will see that if I cover these two graphs, I've covered every possible graph, cubic graph that there is. All right. So that will be dealt with in detail next week. Let's look at the November 2020 paper. You'll see in front of you is the November 2020 paper. My suggestion to you for the preparation of this exam, you can see I've got all past paper questions. Yeah. What are you going to get? First principles. Work through the first principles. What are you going to get? Differentiate by means of rules. What are you going to get? The cubic graph. There's a few questions where you've got to sketch the cubic graph, and there's a few questions where the cubic graph is sketched. If you work through this, you will be well prepared for this exam. Right. And if you want the answers of it, it's on the website. The answers fully worked out is so then you can see whether you're correct or not. Let's look at the following. Right. People, can we just get your attention here? Right, the November 2020 paper. They say GX. Yeah, they say GX is equal to AX cubed plus BX squared plus CX. Right, can I get your attention here? The first question is, for which values of X will G increase? Now people, increase and decrease refers to the gradient, correct? Now, if I use this X value here, do you see? Yeah, for X less than 0, it is what? X, where is it decreasing? So in this case, people, the graph, if we go from left to right, it's decreasing. From left to right, decreasing. From left to right, increasing. Correct. You got to interpret it from left to right. So let's quickly have a look at the following. They say, where is it increasing? So if I go from left to right, do you see it's increasing there? So for which values of X? So in this case, we can say 8.1. For X greater than -1 and less than 2, it increases. The gradient increases. G prime X is greater than 0. Does it make sense? People, let me quickly explain to you this. I'm going to show you how to interpret the question. For which values of X? Will G increase? That, people, is exactly the same as asking, for which values of X will G prime X be greater than 0? G will increase or G prime X greater than 0 means the same thing. Is that clear? So we can see if we move from left to right, for X greater than -1 and X less than 2, it increases. Are you happy with that? People, increasing and decreasing, the values are not included. Okay. I shouldn't say this, but I'm going to say it in any case. There is an explanation why at the end of the year, if they ask you this question, where will it increase or decrease, and you include those values, they will mark it correct. Okay, but strictly increasing and decreasing those values are not included. Is that clear? Why will they mark it correct? Because it is actually a stationary point. It's neither increasing or decreasing there. It's neither increasing or decreasing there, so it should not be included. However, they will mark it correct at the end of the year. There was a question like that in this June national paper, the rewrite paper. There was a question like that. We marked both correctly. Right, whether it was increased, whether it was included or not included, we did mark it both correct. But strictly speaking, we don't include it. Is that clear? Right, the next one. 9.8.2. Write down the x-coordinate of the point of inflection of G. Now, people, the point of inflection is the midpoint. They want the x value for the point of inflection. So it's going to be the midpoint of -1 and 2, correct? The midpoint of the stationary points is your point of inflection for both your x and your y value. They only want the x value for the point of inflection. So we can say, in this case, 8.2, we can say x is equal to -1 plus 2 over 2, and that is equal to half. Where x is equal to a half, that is the midpoint of the stationary point. So that will be your point of inflection. For which x values is it concave down? Now, people, look here. 8.3. For which x values now I need your attention on this one. People, we know if you want to work concave down, f double or g double prime x is less than 0 for concave down. We know that. But you see, they don't give us the equation. So we cannot use it at this stage, correct? We cannot algebraically work it out because they don't give us the values of a, b, and c. So we need to interpret the question. So where do we get concave up or concave down? From the point of inflection, the x value for the point of inflection, which we determined in 8.2. Now, where will it go down? If I say x less than a half, I'm going to finally go up. So that's going to be concave up for x less than a half. Where will it be concave down? If I increase my x values, x greater than a half, I will finally go down, concave down. So if you interpret it, it is x greater than a half, because if I increase the x values, the graph will finally go down, concave down. Does it make sense? All right, so you got to understand the concepts. Next, 8.4. If g prime x is equal to -6x squared plus 6x plus 12, determine the equation of g. Let's have a look at this one. 8.4. Here they say to you, g prime x is equal to -6x squared plus 6x plus 12. Determine the equation of g. What is the equation of g? It's this here, correct? G is equal to ax cubed plus bx squared plus cx. They need the values of a, b, and c. Then I've got the equation of g. Are you happy with it? Right, let's quickly have a look at the following. What am I going to do in order to work out a, b, c? I'm going to take this one, gx. I'm going to say gx is given as ax cubed plus bx squared plus cx. You agree? Now, what is g prime x in terms of a, b, and c? Help me, please. Find the derivative of ax cubed. 3ax squared. Find the derivative of bx squared, 2bx. Find the derivative of cx, c. Fantastic, people. Now, do you understand that what is the coefficient of x squared? What is the coefficient of x squared? Negative 6. What is the coefficient of x squared? 3a. So 3a is equal to negative 6. So a is equal to negative 2. Right, so I've now found that. What is the coefficient of x here? G prime x is this. G prime x is this. So what is the coefficient of x? 6. What is the coefficient of x here? 2b. 2b is equal to 6. So b is equal to 3. Are you happy with it? Right, people, do you see that the constant c is 12? So c is equal to 12. They asked me, in this case, to determine the equation of g. So gx is equal to, a is negative 2x cubed plus bx squared plus c, which is 12x. Are you happy with that? Do you understand that? Great. So that is the equation of g. Now, people, this here is a level 4 question. It takes quite a bit of insight. Determine the equation of the tangent to g at the maximum gradient. Write your answer in the form y equal to mx plus c. Right. I'm going to write down the question. Now, I'm not going to write down the question. You've got it in front of you. Let's quickly have a look. They want the equation of the tangent at the maximum value of g. Correct. So if g prime x we got as that. They want g prime x. The gradient is equal to g prime x, correct? And what is g prime x equal to? 6. This here, a is equal to negative 2. So it is negative 6x squared. If the b value is 3, then it will be 6x plus 12. So what I did is, we know the gradient is g prime x, correct? We want to find the maximum gradient. Now, what kind of graph is this graph here? What kind of graph is it? So again? Right, that is a parabola. Is it arms up or arms down? It's arms down. So at this x value here of the turning point, I will find the maximum x value, and that is where the gradient will take place. Correct. Now, how do I find the maximum x value? At the axis of symmetry. Correct. So what is the axis of symmetry for this parabola? X is equal to minus b over 2a. So this b here is equal to 6. So it's negative 6 over 2 times negative 6. So that is negative 6 over negative 12, and that is equal to half. At x equal to half, I will find the maximum gradient, correct? So what is the gradient of the tangent? It is g prime of a half, which is equal to negative 6 times a half squared plus 6 times a half plus 12, and that will give you a gradient of 13.5 if you use your calculator. 13,5. Are you happy with that? Right, the next one. Now, people, I just want to explain to you that in the application of calculus, which is the next section of work, to find the maximum or minimum, we just find the derivative equal to 0. But we haven't done that yet. So I'm going to use the grade 11 work of the parabola to say at the axis of symmetry, I will find the maximum value. So that's why I use the axis of symmetry to work out the x value, which will be the maximum for this specific graph, and the gradient of the tangent is the derivative at the specific x value, which is equal to a half, which will give me a gradient of 13,5. Does it make sense? Right. Now what we're going to do, if we go back to the GX graph, we can understand it in terms of this. Now people, at x equal to a half is my point of inflection for the GX graph. So they want the gradient of that at that point there. They want the straight line's gradient, the gradient of the tangent at that x value there. So what is the gradient of the tangent? It's 13,5. And what is the point? X equal to half, what's my corresponding y value? That is the point where the gradient will take place on that specific curve. So I've got to substitute x equal to half into the GX equation. And what is the GX equation? The GX equation is given as negative 2x cubed plus 3x squared plus 12x. So the g of a half will give me the corresponding y value, negative 2 a half cubed plus 3 times a half squared plus 12 times a half, and that will give me a y value of 6,5. So what are we talking about? We say the gradient of the tangent is 13,5. The point is x equal to half, y equal to 6,5, correct? So instead of a half, I can write everything as a decimal because I'm going to use my calculator. So at the tangent gradient is 13,5. The point is a half, x equal to half. The y value is 6,5. At x equal to a half, the corresponding y value is 6,5. Is that clear? Now you just work out your straight line equation. Y minus y1 is equal to m bracket x minus x1. So therefore, y minus 6,5 is equal to m, which is equal to 13,5 multiplied by x minus 0,5. Now people, just take note. If you're using this equation to work out the equation of the straight line, this is your x and your x1 and your y1 value, which are substituted into the equation. So we can say y is equal to 13,5x minus 0,25 will be the equation of the tangent at x equal to a half and y equal to, in this case, 6,5. Does it make sense? Are you happy with that? Okay. What I'm now going to do with you is the November 2018 paper. People, next week I will give you the mark allocation per topic. Sequence and series, so many marks. Algebra, so many marks. Calculus, so many marks, etc. And there is one proof that you need to learn for this exam, and that is the sum of arithmetic and the sum of geometric. One of them will be asked, and I'm allowed to say it because we have sent to the schools a message saying the assessment framework is this, but take into consideration that that proof must be known for this exam. The sum of arithmetic and the sum of geometric for paper 1, that proof must be learned. Right, let's look at the following. Right, this is question 9. Right, let's quickly have a look at the following. Right, can I get your attention on this one, please? Okay, people, when we have to find the equation of the cubic graph, we have to find the values of B, C, and D, correct? And that is what they are asking me. Now, the cubic graph has 3 x-intercepts, of which this one is repeated, correct? So I'm going to call, this one is unknown. So I'm going to call it I0. You can call it, I don't want to call it A, B, and C because B is there. So that B can be confused with that B. I can't call it C because that could be confused. I don't call it D. I can call it anything else that's not here. I called it I. Is that clear? So what is the equation of the cubic graph? We know that Gx is equal to, the A value of this is 1. So it is usually A, I'm going to give you the full picture, A, x minus x1, x minus x2, and x minus x3. That is the general equation to find the cubic graph. Is that clear? But however, what is this A value? It is 1. So I leave out the A value and I can put 1. Does it make sense? So this here is negative 5. So it becomes x negative negative 5, x plus 5. And this becomes x minus I times x minus I. So it becomes x plus 5 multiplied by x minus I squared, correct? Does it make sense? Right, people, what do I still know? I know that there is a point on this graph, and the point here is the y-intercept. So 0.20, I'm going to substitute into there. So substitute 0.20 into the equation. So here we can say that 20 is equal to 0 plus 5 and 0 minus I squared, correct? So this here becomes 20 is equal to 5 multiplied by I squared. So here we can say that I squared is equal to 20 divided by 5, which is 4. So I is equal to plus minus the square root of 4, which is equal to plus minus 2. Now take note, I is here on the positive side of the axis. So I can only be I equal to positive 2 because it lies on the positive side of the axis. Does it make sense? Now, people, now I've got my x-intercepts. So now we can say, to find the values of B, C, and D, we can say that Gx is equal to x plus 5 multiplied by x minus 2. X is equal to positive 2, so it's negative positive 2, and x minus 2. Now all I need to do, people, I need to multiply that out. So this here becomes x plus 5, and I'm going to multiply that out. So it becomes x squared minus 4x plus 4. Now I'm multiplying a binomial with a trinomial, grade 10 work, which means it's first by first, first by second, first by third, second by first, second by second, second by third, and simplify. So now it becomes x cubed minus 4x squared plus 4x plus 5x squared minus 20x plus 20. which becomes x cubed. That plus that is plus x squared. That and that is negative 16x plus 20. Are you with me? People, are you okay? Are you with me? Right, now they ask you, what is the value of b? B is the coefficient of x squared. Coefficient of x squared is 1. C is the coefficient of x, and C is negative 16. And D is obviously equal to 20 in this case. So we did show that. Does it make sense? Are you happy with that? Right. The important thing to remember, if the graph turns on the x-axis, that x-intercept is repeated. That's the important thing. Right, 9.2. Calculate the coordinates of the turning points. Now the coordinates of the turning point, people, is P and R, correct? P we already got. I is 2, so that's fine. We've got that one. We just need to find the other one, R. So in 9.1.2, to determine the stationary points, we're going to say G prime X is equal to 0, because that is your stationary point. You can write SP, stationary point, G prime X equal to 0. Let's find the derivative of this. It is equal to 3x squared plus 2x minus 16 is equal to 0. And this here is 3x multiplied by x. And we already know that x equal to 2, right? Negative 2. X equal to positive 2 is the other turning point, correct? So negative 2 times plus 8 will give you negative 16. So therefore x is equal to negative 8 over 3, or x is equal to 2. But this here is a y-intercept, x-intercept, so y is 0. So now we just need to find the g of negative 8 over 3 by substituting it into the gx formula to get the corresponding y value for the coordinates of the turning point. You can just substitute negative 8 over 3 into the equation using your calculator to give you that value. So the coordinates of R is negative 8 over 3. The y value is 1372 over 27. Then the coordinates of P is x equal to 2, y equal to 0. The next question and the last question that I'm going to do with you today . All right, let's quickly have a look here. People, here they say 0.20. Does that point 0.20, is the graph concave up or concave down at 0.20? Okay, so what do we need to do? There's two ways in which we can do it. When is it concave up? I'm going to do the method 1 first. I want you to put down all pens and just listen. Because this, yeah, people, I think it's a more difficult question, because now it's not a straightforward question where you just use the formula. Right, they say to you, 0.20, that point, is it on the graph of concave up or concave down? Now, what is concave up? G double prime of x greater than 0 is concave up, correct? So let's find G double prime x. G double prime x. What is the derivative of G prime x? Is that? What's the derivative of that? 6x plus 2 is equal to 6x plus 2, correct? Now, what is your x value? Your x value is 0, correct? So I'm going to substitute x equal to 0. So 6 times 0 plus 2, that is 2. People, do you understand that the G double prime x is equal to 2? It's greater than 0, correct? Do you understand that G double prime of 0 is greater than 0? It's equal to 2. And if G double prime x is greater than 0, what is it? Concave up. Are you with me? People, this is a different way of looking at it. They give you a point. They ask, is that point concave up or concave down? So we know that when is it concave up? If G double prime of x is greater than 0, it is concave up, correct? Now, G double prime x, I find that this is G prime x, which is equal to 3x squared plus 2x negative 16. G double prime x is equal to 6x plus 2. By substituting the x value, I will get a corresponding y value. And in this case here, the G double prime of 0 is 2. And G double prime x, that value 2 is greater than 0. So it's concave up. Because G double prime x is greater than 0. It's 2. Therefore, it's concave up. Method 2. It's a more difficult question, people. But when you teach and when you prepare, you must always prepare there. Because if you prepare there, everything else below that you will get right. So this is a more difficult question, and I'm sure that what we've done so far, if you can master what we've done so far, you will do extremely well. Let's have a look at this. I need your attention. Method 2. Right. The other point which we need to determine is your point of inflection. People, if I can find a point of inflection is the midpoint of the stationary points, correct? So you could find the midpoint of the stationary point for x. We know this here, P here is 2, 0, correct? And R here is equal to negative 8 over 3. R is equal to negative 8 over 3 and 1372 over 27. So if I find the midpoint of this, I will find my point of inflection. Is that clear? I will find my point of inflection. So I'm going to find the double derivative. The double derivative is equal to that. Agree? So G double prime of x equal to 0 is my point of inflection. So we can say this here, 6x plus 2 is equal to 0. 6x is equal to negative 2. X is equal to negative a third. Are you happy with that? Now, people, if x is equal to negative a third, do you see negative a third is here? Negative a third. Do you see that after negative third, it's going to go up? Less than or greater than negative a third will go up. So do you see this point lies on this side where it is greater than negative a third? So it's going to be concave up. Is that clear? Because naught, x equal to naught, lies on the right-hand side of negative third. X greater than negative third is concave up. So this point lies on concave up. Therefore, naught 20 lies on concave up. My honest opinion is that is the easier method. If you can find your point of inflection, How do you find the x value for the point of inflection? It's the midpoint of -8/3 plus 0 divided by 2. It's the midpoint of the x values of the stationary points. Or if you use your formula, f double prime x is equal to 0, then 6x plus 2 is equal to 0, therefore x is equal to -1/3. Both methods will give you x equal to -1/3. Now, 0.20 lies on the right-hand side of -1/3. For x greater than -1/3, it will be concave up. Because greater than -1/3, the point will finally go up. For x less than -1/3, it will finally go down. X less than -1/3 is concave down. X greater than -1/3 is concave up. That is the easier method of the two. Sorry? You are absolutely there. G prime x, took it across. Okay. Right, people, that brings us to the end of this class.